It's day 5 at the Mukuba UniPod of the residency program, and we are joined yet again by one of the teams that have been taking part in this prototyping stage. These people have been prototyping for the past 4 days, and today is the 5th day that they are working on this prototype. And just before we go any further, we'd just like to know you. So kindly tell us your names and the institutions you come from.
Okay, my name is Manuel Tembo, secondary engineering student here at Mukuba University.
Okay.
My name is Clean CookTeam, fourth year student at Mukuba University, doing Bachelor's of Science in Computer Science.
Amazing to hear that. We are glad to have you here at the Mukuba UniPod, and definitely we know that you took part in one of the hackathons for you to be here. So kindly just tell us, which hackathon did you take part in?
So we took part in the Let There Be Light hackathon.
Okay, and how was your experience during that hackathon?
I can say it was quite challenging from the word-go, because we are following a certain methodology in which to approach a certain problem and how to create a solution around that problem. But it really created an environment where we got to meet new people, how to work with people, and how to bring ideas together as a group, solving real-life problems.
Amazing. So definitely during that hackathon you were given a problem that you were addressing and working towards. So just tell us, what problem were you addressing?
Okay, so for us, we were focusing on the renewable energy sector.
Okay.
So in the renewable energy sector, we discovered the problem that was there was that charcoal and unreliable green was having effect on households and also SMEs, small medium enterprises.
Amazing. And so there are people out there who could be listening to this for the first time, and they just want to find out, what solution did you come up with to that problem that you were addressing?
So the solution that we came up with is Clean Cook. So Clean Cook is an innovation or an idea that uses hydrogen gas for cooking. Like I earlier stated, people and households and also small medium enterprises use charcoal and other alternative sources such as liquid petroleum gas, and which also affects the environment and affects the world at large. But Clean Cook uses hydrogen, which mitigates that problem that we earlier highlighted, eliminating liquid petroleum gas and also moving away from the use of charcoal and also the reliable grid, which is zesto, and that is Clean Cook, the use of hydrogen gas.
All right, thank you very much. So out there could be potential investors watching this, and they would just be interested to look at a prototype. So we'd like you to just show us what you have worked on and just how this innovation works, so that people out there can see and just have a feel of it.
So for Clean Cook, it uses hydrogen, like earlier stated. So as we can see here, we're having a stove. So this is the model of a stove. So a stove, but before we use the stove, we need to be able to produce hydrogen safely and green, which is green hydrogen. So we use the process known as electrolysis. So electrolysis uses electricity to separate hydrogen from oxygen, which is in water. Then in here, in this container here, we use an electrolyte known as sodium chloride, which is the common household salt. So in this container, we have sodium chloride. Then we have on the anode here, which is the positively charged, we connected the nail, and then in this tube we have the cathode, which is negatively charged. So at the cathode is where the hydrogen gas is being produced, and then the hydrogen gas that is produced on the cathode is it moves through this tube and is collected in this balloon that you see here. So in this balloon here, this balloon is filled with hydrogen gas. We've managed and successfully produced hydrogen gas, but due to limited resources, the sodium chloride that was used in this experiment produced chlorine gas. So the chlorine gas is what you're seeing now, having all this effect, and also there was the chemical reaction that happened on the anode. Due to the lack of proper resources, we were unable to use the proper material for the anode, and that's why we can see oxidation happening on the anode, and that's why we see all these color changes. But production of hydrogen on a large scale can be used, and also we can be able to produce clean hydrogen gas that can be used for cooking in our small model stove. So this is our prototype, the production of hydrogen gas using electrolysis, and this is some sort of a short demo on how we can be able to produce electrolysis using renewable energy, which is most likely we want to use solar energy, but due to lack of resources, we've used hydro, which is also a renewable energy source. So here we have in hydro producing, giving us 28 volts of electricity that has helped us produce the hydrogen gas that you see in the balloon. And then from the balloon, we use the hydrogen gas into the stove, and the stove is right here.
Amazing, amazing. Thank you very much for sharing with us the innovation that you have been working on. And just before we close, what help have you received from the Mukuba UniPod throughout your innovation, all the way from ideation and up to this stage you're at right now at prototype? What help have you received from the UniPod?
So for our project, like I've mentioned, it's an experimental project. So this is not our first trial. The Mukuba UniPod has provided us with the technical support, and also this the voltage that we're receiving here, and also all these materials that we've managed to use here were provided by the Mukuba UniPod. We first started with the use of we used salt, and we use salt, and we've also tried using baking soda. So we've been experimenting throughout. So the Mukuba UniPod has helped us come up with something that can be able to actually produce hydrogen gas, because in the earlier stages of our prototyping, we had technical failures, because this is an experiment. There were a lot of chemical reactions that were taking place. So the Mukuba UniPod has helped us throughout the way, and has helped us find a better way in which we can perform this separation of hydrogen from water using electricity.
Thank you very much for sharing with us. And as Mukuba UniPod, we are excited to have you be part of this program and for sharing your innovation with the world. We definitely look forward to this project reaching its success and reaching the market so that people can get to use the solution that you have brought for us. So thank you very much for being part of this program, and keep innovating.